Oh, that worked.
Hola.
That worked. You want to begin?
Buenos días.
All right. This is our independent lab. You probably saw it in the back for a while back there. What we did was we just created a marble track, and we were trying to find kinetic energy and just see what the ball does while it goes through a vertical loop and a horizontal loop.
And see kind of like, would the kinetic energy change during the loop for each loop? And what we found
Those are just some pictures.
was, so this is our the data from the horizontal loop. And as it went through the loop, the horizontal actually increased. Because, I mean, looking at it, it's really just a downhill that just kind of turns. Like, you can see right here, it's just basically going, it's still going downhill. And that there's just in a circle, but nothing too exciting. Not like the vertical loop, which actually like goes up and fights against gravity more.
We made roller coasters.
Sure.
Okay, so we were finding, all we did was we started at a starting height, which you didn't even save it, man. Again.
What? Save it. What?
Dude, it's still in meters. We're not dropping.
That's centimeters, by the way, not meters.
Huh.
We're not dropping full 14. There we go. That'd be awesome.
That would be awesome.
Anyway, we started where the marble would barely start going down the horizontal loop, so that's where we started our data, and we stopped our data when the marble would fall off. So really what's happening when it falls off is it loses all friction.
There wasn't enough like friction or normal force to keep it on the track, so let me draw some.
Do a diagram, man.
Okay.
Better show.
So that's our marble. That's the normal force by the track, and that's mg. Sure. Okay, so now as it would go through the loop, it would be accelerating from the energy that it picked up from the ramp. But like when it got to the turn, it would have too much momentum, and then the only thing keeping it on the ramp, on the track, would be the side rail, which didn't have like enough force to exert to keep it in the loop.
Is this a top view?
Top view,
yes.
indeed.
Of the horizontal loop.
And then we did the vertical loop, and we kept the height constant to keep the velocity about the same.
No, we didn't.
Oh, we did. Oh, didn't we?
No, we didn't.
Oh, we didn't.
No, we changed height. And
lied.
but not instead of like going up at starting heights, we went down at starting heights to see when like it wouldn't have enough energy to complete the whole loop. That one wasn't really based on centripetal force. It was just based on like amount of like momentum to keep it going up and over the loop. And for this one, kinetic energy actually went like decreased through the loop, which I thought was kind of weird because I thought it would just like be the same, like when you throw something up in the air, if you catch it at that same starting point, it'll have the same speed as when it left. But I'm guessing that some of the energy was lost to friction from the actual rolling movement.
And just to say that we kept the ball did not slip, so we didn't have to worry about any issues with that.
That's it.
Any questions?
Cool. Let's thank our speakers.